Welcome to this explainer. Okay, imagine for a second that you're tasked with finding out exactly why a multi-million-dollar ad campaign just totally failed. The catch? Your data is this incredibly tangled web of human emotions, sales figures, and random website clicks. How do you even begin to make sense of that? Well, today we are going to tackle that exact challenge, deciphering incredibly complex data sets in research and data analysis. If you've ever stared blankly at a massive spreadsheet and wondered how on earth to find the hidden structural patterns buried inside all those numbers, you are definitely in the right place.
So let's really dive into this. How do fields like psychology, the social sciences, or marketing actually measure hidden, underlying variables? Think about it. Let's say you're an organizational psychologist, right? And you're studying employee burnout. You obviously can't just put burnout on a scale the way you'd weigh an apple. Instead, you have to measure these complex human constructs through completely indirect means. As researchers, we need to confidently put a hard number on something you can't physically see or touch, like human anxiety, customer loyalty, or, burnout. The big question is, how do you actually do that accurately without just guessing?
Here is our roadmap for today. We'll start with 1, the complex data challenge. Then 2, decoding SEM basics. 3, how Amos simplifies SEM. 4, advanced analysis capabilities. And finally, 5, pros, cons, and a quick FAQ.
Part 1, the complex data challenge.
Enter SEM, or structural equation modeling. Now, I know it sounds like a massive mouthful, but SEM is basically your ultimate key for statistically testing theoretical models when you're dealing with a ton of variables. Think of SEM kind of like a weather system. You don't just look at the temperature all by itself, right? That would be like running a standard regression. Instead, you're looking at how atmospheric pressure, wind speed, and humidity all interact simultaneously to create a storm. By combining elements of factor analysis and multiple regression, SEM lets you evaluate this whole complex web of relationships between the variables you measure and the underlying constructs you're trying to understand. And it does it all at once.
Section 2, decoding SEM basics. To really get this, it helps to think of your data in 2 distinct buckets. First, you've got your observed variables. Think of these as the footprints. They are the actual data points you directly measure in your research, like a respondent's exact score on a daily survey asking about their energy levels. Then, in the second bucket, you have latent variables. This is essentially the monster in the closet that's making the footprints. These are the underlying concepts, like the actual feeling of employee burnout, that you can't directly observe, but you mathematically infer them based on how those measured survey variables behave.
To round out our basics, we have 2 more really vital components. First are paths. Paths literally connect the dots in our data. They draw the map of direct or indirect relationships, basically showing us what causes what. But then there are error terms. Because, let's face it, human beings are chaotic. Error terms are there to account for the messy reality that your model just cannot explain. Like, say, a survey respondent giving totally random answers just because they haven't had their morning coffee yet. No model is absolutely perfect, and error terms are just our way of mathematically acknowledging that human unpredictability.
Moving to part 3, how Amos simplifies SEM.
Now, if you have ever tried to write hundreds of lines of really complex coding syntax, you know the absolute pain of traditional data modeling. It's tough. And this is exactly where Amos comes in to act as a bridge. Developed by IBM, analysis of moment structures, which we just call Amos for short, takes the heavily mathematical, often code-based process of SEM and flips it into a highly visual drag-and-drop experience. Literally, instead of fighting with endless lines of code, you are essentially drawing your hypotheses. You just drop circles and squares right onto a digital canvas to build your structural equations visually. It's a real game changer.
So here is how the workflow actually plays out. In step 1, you visually construct your models, completely skipping the complex syntax. Then, step 2 uses what's called maximum likelihood estimation. Honestly, that's really just a fancy way of saying the software does the heavy lifting to mathematically find the most statistically probable answer for how your variables relate to each other. And step 3? Step 3 is an absolute lifesaver. Using advanced techniques, Amos can actually patch the holes in incomplete datasets without ruining your results. This is absolutely crucial, because as we all know, real-world datasets are incredibly messy, and they are almost always missing a few data points here and there.
Section 4, advanced analysis capabilities.
So once you're in Amos, what kind of heavy lifting can you actually do? Well, first, confirmatory factor analysis lets you test if your hard data actually fits your hypothesized model. Second, you have path analysis, which dives deep into those direct and indirect relationships. So it helps you see if, say, social media use directly causes stress or if the relationship is just indirect. Third, there's multigroup SEM. This is super cool because it lets you test if that exact same stress model works identically for, say, Gen Z versus baby boomers. And finally, moderation and mediation analysis tests how third variables act as influencers. So for example, testing if getting 8 hours of sleep acts as a buffer that completely changes the relationship between stress and burnout.
Finally, Section 5, Pros, Cons, and FAQ. Let's talk about why you'd want to use this. The biggest real-world benefit here is time. Instead of fighting with code errors for 3 hours straight, the intuitive visual interface lets you build and test your model in minutes. Plus, the powerful algorithms behind the scenes ensure high accuracy in your estimates, and the sheer range of analysis options gives researchers incredible flexibility. Beyond that, the software generates these gorgeous path diagrams and detailed fit indices that you can easily drop right into your final research report. It guarantees a workflow that is both highly reliable and super efficient.
But let's ground our excitement a bit. It's not completely perfect. Because it is proprietary software, it does require a paid license, which, let's be honest, can certainly hurt a student's wallet. More importantly, while drawing shapes on a screen is incredibly easy, you still absolutely need to understand the underlying statistical math. Without a foundational grasp of SEM, it's entirely possible to draw a beautiful model that is mathematically useless. And finally, if you're trying to build extremely complex, massive models with tons of variables, you are going to need significant computational resources to actually run the analysis.
Now you might be thinking, what about open source options? Well, if you prefer the hardcore open source route, the statistical programming language R has a totally free package called Latent. It gives you deep, granular control over every single aspect of your model. But, and this is a big but, it strictly requires you to write and debug code. So when comparing the two, Amos essentially trades that maximum customization for an incredibly approachable user interface. If you want a smooth, visual canvas rather than dealing with complex coding syntax, Amos is widely praised as the superior tool for sure. A very common practical question: can your computer actually run this thing? The good news is, you do not need a supercomputer. Amos basically just requires a standard Windows machine with a minimum of 4 GB of RAM to get started. It's built to run perfectly fine on standard modern processors and really just requires enough disk space to store your datasets and those detailed visual output reports we talked about. This means you can do advanced, robust data science right from your average, everyday laptop. So now that Amos makes structural equation modeling so incredibly accessible, what unseen patterns are waiting to be discovered in your own research? By turning complex mathematical coding into an intuitive, visual, drag-and-drop experience, Amos really empowers you to test sophisticated theoretical models with absolute confidence. With the barrier to entry lowered like this, what unmeasurable concepts will you finally put a number to? Thank you so much for joining me for this explainer. Now go out there and unlock the hidden structural relationships in your own data.